All right, today we're going to be talking about simple probability. Probability of simple events, and then we're going to use the sample to predict some values for a larger group. So some new vocabulary, we're going to talk about theoretical probability and experimental. Theoretical is what we're going to figure out what should happen. Experimental is like if we actually go and do the experiment, what will we have? Theoretical probability says that every time I flip a coin, one time it's going to land heads, the next time it's going to land tails. But we know if we actually tried that out, not every single time will it flip between the two of them. It will go ahead and sometimes we'll get a couple heads in a row or a couple tails in a row. But if we did this long enough, it's going to end up being very much like the theoretical probability, 1/2. All right. So simple probability. Probability of an event is the number of favorable outcomes, the number of positive outcomes, divided by the number of possible. So how many of them are favorable, how many of them are desired, or those positive outcomes, and then the total possible number of outcomes, or how many things can occur. It is a fraction. The probability will always be less than 1 and greater than 0. So it could be like 1/5 up to 4/5 and even 5/5. It could be 0/5, 1/5, 2/5, 3/5, 4/5, 5/5, so on and so forth. Or any kind of fraction, 10 over 75. Of course, that one would need to be reduced, but other ones, any of those kind of combinations. We'll never get negative numbers, and we'll never get improper fractions like 1 and 2/3, because we have to stop at 1. All right, so suppose a number cube, a die, is rolled. What is the probability of rolling a 4 or 5? Well, most of you know a die, or dice, have 6 sides, most of the normal ones. So let's just talk about a normal 6-sided die. On a 6-sided die, there's 1 4 and 1 5. So there are 2 possibilities out of a total of 6 sides. So 2 numbers are 4 and 5, obviously the 4 and 5, and there are 6 possible outcomes, 1 through 6. So in other words, we do 2 out of 6. Now we do have to reduce always. It's a fraction. We do have to abide by our laws, which say 1/3. So the probability is 1/3 or 33 1/3%. We're going to, with probability, mostly stick with the fraction right now. When we get into later statistics, we will move back into percentages because it's a little bit easier at that point because we're dealing with a lot bigger sets of data. But at the lower end here, we like to keep it just as the fraction, so 1/3. All right, what's the probability on the spinner of spinning a blue or a green? Now, how many blues are there? There's 3 of them. Excuse me. And how many green sides are there? There's 2 of them. So blue and green total, there's 5. How many total slots are there? Well, there's 8. So therefore, we have 5 out of 8, or 5/8. Now, what if we roll 2 number cubes? So 2 dice. Find the probability of rolling 2 identical numbers. First and foremost, we have to know what's the possibilities. What could we roll? We could roll a 1 and a 6, a 2 and a 6, a 3 and a 6, a 4 and a 6, a 5 and a 6, a 6 and a 6. Well, then we could roll a 2 and a 1, and a 2 and a 2, and a 2 and a, all these different possibilities. So sometimes it helps to go ahead and have a chart that we put out. And these are all the different possibilities of rolling a die. The first die could be 1 through 6, and this one's 1 through 6. And so we have a 1 and a 1, and a 1 and a 2, and a 1 and a 3, and a 1 and a 4. All these different possibilities that we can occur. Now, there are 36 total of them. Now, when we're looking here, it says for 2 identical numbers. Well, a 1 and a 1, a 2 and a 2, 3 and a 3, 4 and a 4, 5 and a 5, 6 and a 6. So there are 6 different combinations out of the 36. 6 outcomes, 6 out of 36, or down to 1/6. Again, they put it in a percentage if you'd like, but it is 1/6 of the time you should roll doubles. All right, what if we want to find a sum who's 8? Well, what are the possibilities to get 8? We can have a 6 and a 2, but don't forget we can also have a 2 and a 6, a 5 and a 3, and a 3 and a 5, and a 4 and a 4. There is no backwards for this because there's only one possibility. It's actually all these numbers right here, kind of going up here in this diagonal. So that's 5 out of 36. That can't be reduced, so that's just our answer. So what about experimental probability? All of that was theoretical. This is what should happen. What happens if we actually did it? So someone went ahead and tossed a coin 40 times. The heads came up 18 times. What's the probability of getting tails? Be careful of what was asked. Heads came up 18 times, so how many tails were there? Tails, there was actually only 22, or actually there was a lot. There's 22 out of 40, and then of course we have to reduce that to 11 out of 20. So that is our probability, 11 out of 20. Is it exactly that 1/2 that we should expect? No, but it's pretty close. And sometimes that is what happens. Sometimes with the experiment, we get a little bit off. So let's try another one. Brian is shooting baskets. He makes 13 shots and misses 9. What's the probability of Brian making a shot? Well, 13 should be our numerator because he makes 13. But it's not 13 over 9. It's 13 over the total. And the total is 22. So 13 over 22. All right, so now we want to make a prediction. Miss Newman surveyed her class to see which sports they preferred watching. 44% said football, 28% said basketball, 20% said soccer, and 8% said tennis. Out of 560 students in the entire school, how many would you expect to say prefer watching basketball? She's taking the information from her class and saying, if this is a normal class, what would the rest of the student body look like? We can go ahead and extrapolate that information and come up with an estimation of how many students would like to watch basketball. So the total number of students is 560, so 560 is the base, and the percent is 28%. So what number is 28% of 560? So we need to go ahead and write this out. So what number, that should be our variable, is an equals. 28% is 0.28, of is a times 560. So A equals 0.28 times 560, which is 156.8. Of course, we can't have 0.8 of a student, so we're talking about 157 students, approximately. All right, let's do this again. Now, people in the art class were surveyed about their favorite color. 32 said blue, 29 red, 23 yellow, 16 green. If there's 450 kids in the student body, how much would you guess would prefer red? So again, we take that 29% times 450 is 130.5. Again, we got to round, so 131 students. All right, that's what I have for you today.